Hello and welcome to this Jupiter notebook. My name is Isaac and I will be your guide through this analysis of Ironman 70.3 races from 2004 to 2020. In this notebook, we will be exploring a dataset of over 840,000 records of Ironman 70.3 pro and recreational triathletes, including their gender, country of origin, age group. Our goal is to exercise several descriptive and inferential statistical methods and techniques, as well as build a XGBoost predictive model and use different model interpretability tools to explore how each of the predicting variables contributed to the model predictions of the race time. Let's get started. In the first code cell, we will be importing the necessary libraries for our analysis, including Pandas, NumPy, Matplotlib, Seaborn, and XGBoost. We will also be loading the Ironman 70.3 dataset into a Pandas data frame using the read CSV function. In this code cell, we will be loading the Ironman 70.3 dataset into a Pandas data frame using the read CSV function. We will also be displaying the first 5 rows of the dataset using the head function to get a glimpse of the data. In this code cell, we will be applying the functions we defined in the previous cell to the dataset. The first function, time in seconds, calculates the number of seconds from the time in the format in ses. This function is applied to the raw data for creating a column time ses. The second function, time in seconds 2, calculates the number of seconds from the time in the format in ses. The third function, time in less, calculates the time as ses from the number of seconds. This function is used to convert the time ses column back to the original format. In this code cell, we are setting up our Jupyter Notebook environment for data visualization and analysis. Firstly, we are using the %matplotlib inline command to display any charts or graph we create directly in the notebook. This means we don't have to open a separate window to view our visualizations. Next, we are ignoring any warning messages that may appear during our analysis by using the warning filter warnings in your command. This is helpful because sometimes warning messages can be distracting and not relevant to our analysis. We are also defining a graphics style using PLT style. Use a Seaborn white grid. This sets the style of our charts to a white grid background with clear lines and markers. To ensure our data is displayed with the appropriate precision, we are setting the display precision to 2 decimals using PD set option display precision 2. Lastly, we are defining 2 colors to represent males and females in our charts. The color for males is set to royal blue and the color for females is set to orchid. These colors will be used throughout our analysis to differentiate between genders. In this code cell, we are using the oswalk function to search for files in the /kaggle/input directory. This directory is where our data files are stored. The oswalk function returns a tuple of 3 values: the directory path, a list of subdirectories, and a list of files in the directory. We are only interested in the files, so we are using a for loop to iterate through the file names and print out the full path of each file using the osPathJoin function. In this case, we only have one file in our input directory, which is the half Ironman df6 CSV file containing data on Ironman 70.3 races between 2004 and 2020. The output of this code cell confirms that the file is present in the directory and we can proceed with our analysis. In this code cell, we are reading in the data file half Ironman df6 CSV using the PD read CSV function from the Pandas library. First, we define the path to the file using the path variable, which is set to /kaggle/input/Ironman-703 race data between -2004 and -2020/. Then, we define the name of the file using the file variable, which is set to half Ironman df6 CSV. Next, we use the PD read CSV function to read in the data file. We pass in the path and file name using the path plus file syntax. We also specify the separator as using the sep equals parameter. Finally, we set warn bad lines equals true to display any warnings about bad lines in the data file. We print out reading files to indicate that the file is being read, and then print out done once the file has been successfully read in. In this code cell we are using the df-info function to get information about the data frame df. The output shows that the data frame has a range index of 840,075 entries, with 13 columns. The data columns section shows the name of each column, the number of non-null values in each column, and the data type of each column. We can see that there are 5 columns with object data type and 8 columns within 64 data type. The memory usage section shows the amount of memory used by the data frame. This information is useful for understanding the structure of the data frame and identifying any potential issues with missing values or data types. In this code cell, we are using the df_ascribe function to get descriptive statistics about the data frame df. The output shows the count, unique values, top value, and frequency of the top value for each column. For columns with non-numeric data types, the count and unique values are shown, but the other statistics are not applicable. For columns with numeric data types, the mean, STD, min, 25%, 50%, 75%, and max values are shown. This information is useful for understanding the distribution of values in each column and identifying any potential outliers or issues with the data. In the upcoming code cell, we will be analyzing trends in performance and the number of participants over the years. In this code cell, we are printing out the breakdown of male and female records in the data frame df. We are using the value counts function to count the number of occurrences of each unique value in the gender column. The output shows that there are 635,680 records for males and 204,395 records for females. This information can be useful for understanding the gender distribution in the data and potentially identifying any gender-related trends or biases. In this code cell, we are analyzing the trends in the number of finishers by gender over the years. We first create two new data frames, female finishers by year and male finishers by year, by filtering the original data frame df for only female and male records, respectively, and then grouping the data by the event year column and counting the number of records in each group. We then create a plot using the Matplotlib library to visualize the number of finishers by gender over the years. The plot shows two lines, one for females and one for males, with the x-axis representing the year and the y-axis representing the number of finishers. We also add a secondary y-axis to the plot to show the male-to-female ratio over the years. This is done by dividing the number of male finishers by the number of female finishers for each year and plotting the resulting values as a dotted gold line. This information can be useful for understanding the trends in participation and performance by gender over the years. In this tutorial, we have explored how to analyze and visualize data using Python and Jupyter notebooks. We have covered various techniques such as data cleaning, filtering, grouping, and plotting using libraries such as Pandas, Matplotlib, and Seaborn. By following this tutorial, you should have a good understanding of how to work with data in Python and how to use Jupyter notebooks to document your analysis and share it with others. Remember, data analysis is an iterative process, and there is always more to learn and explore. So keep practicing and experimenting with different techniques and tools to improve your skills. Thank you for watching, and happy analyzing.